Okay, so Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Al-Amri, a course lecturer for Advanced RC Design. I would like to welcome all of you for the beginning of this particular semester. We have met, I think, some of you, if not all. Just to brief you, since this is the first day, Ahmed Al-Amri is a graduate from the Higher College of Technology, or was a graduate of Higher College of Technology in 2012. He went to complete his master's degree in the UK in 2014, and then he started his teaching career in 2015. And then since that, he was a program coordinator or program director of engineering for 3 years. Later on, he went to the ministry for 1 year for certain works and then returned back last February. Okay. Once again, it's very nice to welcome all of you. I believe we have met in the projects a lot. If not, then I would welcome you once again. Okay. Today's session is going to be the introductory class about Advanced RC Design. Most of you have finished, all of you have finished Design of Structures 1, but I'm assuming that a lot of you have forgot a lot of things about it, about Design of Structures 1. So we are going to have a recap of whatever you have studied. Okay. One thing before we start the actual class, I like my classes to be interactive. Okay. So try to make sure that you are interfering. Okay. Interfering at any time. If you didn't understand any point, you can directly stop me and tell me to repeat. Okay. Keep it interactive rather than me teaching and then starting to be okay. Okay. Are you able to see the screen? Okay. Okay. So once again, after each and every class, I'm going to upload for you the PowerPoint presentation, or would you prefer me to upload them upfront? Would you like me to upload for you the presentations and the handout? The presentation after the class or before the classes? Before the class. After the class. Before. Okay, no problem. Since the majority are saying before, since the majority are saying before, starting from the upcoming class, I'm going to upload for you the presentation for the upcoming lecture. Okay. Now, one thing to be taken into account, there is a handout and there is presentation. The handout that I'm going to give you is not only a handout for Advanced RC Design. That handout is going to be a recap of whatever you have studied in Design of Structures 1. It has a lot of solved problems. It has a lot of things from Advanced RC Design, and then it has a lot of things from things you will require for your project, like analysis and design of staircase, analysis and design of lateral loading, including seismic and earthquake. So you can study from both of them. the presentation are going to be summarized. They are going to be for the course itself. If you require more problems or your project work, then you can refer to your handout, and I'll show you at the end of the session. I'm going to show you the handout as well. Are we okay with that? Okay. So the first thing that normally we start with, is the mark distribution, and this is the most important part for you. Now, this semester is a little bit different from the previous semester or the other semesters. This semester is going to last only for 8 weeks, and according to that, the assessment might slightly be different from whatever was there in the last semester. It's yet to be confirmed. It's not yet confirmed, but this is the proposed one, and we are assuming that this is going to be the final decision. Now, previously, the assignment in the previous semester was for 10 marks. It is proposed that this semester assignment is going to be for 15 marks. I'll try my best to supply you the assignment within the first 2 weeks. The assignment is going to be about a full design of either single story or 2-story building. It's going to be individual, where you are going to be asked to design slabs, beams, columns, foundations using manual methods, not using software. Okay, so it's going to be a good preparation for you for your final examination. Whether it's going to be a single story, whether it's going to be a 2-story villa, whether it's going to be a group or individual, I'll keep you updated depending on the situation of this particular semester. There will be only one quiz. Previously, there were two tests. Now we are going to have only one quiz. That quiz is going to be for 15 marks. Okay? So one assignment, one quiz. Each one of them is for 15 marks. Then we are going to have a midterm examination. Last semester, there was no midterm. There were only test 1 and test 2. Now we have midterm and we have quiz. Okay, one quiz and one midterm. Final examination is going to be for 50 marks. And the assignment, as I told you, normally it's going to be a structural design of a 2-story building or a single story, depending on the situation and circumstances for this particular semester. Are we okay with that? Any question regarding your assessment criteria before we start? We used to show the students our course delivery plan, but since it's not yet confirmed till now, whether we are going to have the quiz in which week or the midterm in which week, whether these are going to be the final decision. So I would rather postpone showing you the delivery plan till another time. Okay. So going to the core of the course, we're going to have different things in today's lecture, different topics to be discussed in today's lecture. We are going to have why RC, why reinforced concrete, why not any other material, and then we have RC components. What are the different components of reinforced concrete? We are going to have building and views, structural and architectural drawing, structural element, what are the different structural elements, and then finally the different structural systems. Now these things you should have already studied, whether it's going to be in design of structures 1, whether we are talking about building drawing, or even theory of structures 2 or 1. So this is going to be a recap. just what you call to make you prepared for the course of advanced RC design. Okay. Now, first part says for you, why RC? Can anybody tell me why we are using concrete? Why do we use reinforced concrete? Why not any other material? You can unmute your mic if you want. Keep it interactive so you'll not be bored and you will learn.
Yes, sir. It is
Yes.
better for the compression. Sorry.
Okay. So, for example, if we refer to structural steel, which one is stronger in compression?
About the steel, it is tensile tension. I mean.
Okay. Now, once again, just to keep it clear, we have something called structural steel, and we have something called rebar. The rebar is a steel bar, and then we have structural steel. This is what you have studied in design of structure steel. Okay. So, if we have a steel column, not a concrete column with steel bars, steel column, will it be good in compression or not? It will not be good in compression. Okay. Others, can we hear others? So we'll discuss further. Can we hear from the others? Once again, keep it interactive so you will learn. Okay. Since all of you are sleeping, then we'll continue with Rashid. Rashid, if I have a steel, column and I try to compress it, I try to put a load on this particular column, will it be effective? If I have a steel column and I'm trying to apply a load, will it be effective? Rashid, see, use your logic when you are trying to analyze things. It's a steel column. If you are having a steel column and I'm trying to apply load, will it be effective? It's a steel column. It's a steel element, not a bar. Okay. Ignore whatever you have studied previously. Use your logic to analyze things. Okay. Use your logic to analyze things. If we are having a steel column and we are trying to apply load to it, can I say that the steel is not good in compression? Can I say that the steel is not good in compression? Okay. Others? Okay. What are the different materials can be used for construction? What are the different materials that can be used for the construction other than concrete? If I want to build my house, what are the different materials that can be used other than concrete? And when I say material, I refer to structural materials. Structural materials. Okay, so we have timber, stone, okay, and then we have steel. Other than steel, other than timber, you cannot build a full house of cement. Previously clay, Okay, so brick, stone, blocks are referred to masonry. So we say masonry buildings. Okay. So we have mainly, if we talk, we have mainly steel, we have concrete, we have timber, and then we have the last one, which is glass. Okay. With the clay or masonry, let's say. Okay, so once again, we have concrete, we have steel, we have wood or timber, and then we have glass. Masonry or clay can be added. Why cannot we use wood in Oman? Why don't we use wood for the construction of buildings in Oman, if wood is possible to be used? Now, if you used to see a lot of movies, you will know that a lot of countries are using houses from wood or timber. Like in the United States, they are using a lot of houses which are made of wood or timber. Okay. So due to the weather, or due to the temperature, or due to the humidity. Okay. So humidity, no, it's not about the type of wood, it's about the temperature, weather, humidity. Okay. So the weather that we are having, man, it's not suitable for wood to be used. Are we clear about that? Are we clear about the wood? Are we clear about the wood?
Yes, Mr.
Okay. And then we have glass. Nowadays there are glass panels, which are glass slabs, and we have glass fins, or whatever we call them as glass beams. Okay. So why not to use glass? Do you think
Also because the heat, weather?
No. You can do some kind of a layer to stop the heat from affecting your building. What is the big issue when it comes to the glass? Why we cannot use it here in Oman? Why you cannot have your building full of glass, other than being expensive? When it comes to expensive, you need to relate how expensive it is with how much load it can take as well. The biggest problem, can we say that the biggest problem? No, there are certain types of glass that are not easy to be broken. Can we say that the unreasonable, easy? Why don't we have in our buildings now? Why don't we have a lot of glasses? A lot of windows, a lot of glasses in the buildings, other than heat and temperature. Glass is stronger than concrete, by the way, when it comes to load capacity, other than municipality rules. Why the municipality says for you cannot have a lot of glass?
Because of heat.
Can we say because, no, other than the heat? Can we say because of the privacy?
Heat proof.
Glass will not give you privacy. Can I say like this? Other than heat can be solved. Heat
Yes,
can be
privacy. Yes.
Can I say because of the privacy? Glass is not going to provide you any privacy. The community, whatever society you are living in, requires privacy, right?
But we can solve this, Mr. With films.
Right.
There is special films.
Special
when coming to the glass.
Can work for a certain time, for a certain period, with certain lights. Okay, so one big issue when it comes to glass, which is not visible to be made of, is the privacy. Okay, so we have the privacy and then the temperature as well. Are we fine? So that's why we don't use buildings which are made of glass. No. What about structural steel? So we talked about timber, we talked about glass. What about steel, structural steel? Why most of we are using structural steel? A lot of commercial buildings, a lot of big buildings, a lot of warehouses are only made of structural steel, means steel column, steel beam. Why do we use?
Because of cost, Mr.
Okay. One of the
Cost
things.
will be high.
Okay. One of the issues, because of the cost. Other than that, because of the durability, we say. Okay. Because of the durability and because of the temperature. Now, is there any problem? Is there any problem for the steel regarding the durability? Since you have studied materials, no? Do we have a problem for the steel in terms of durability? What is the meaning of durability? What's the meaning of durability? Yes, durability. There is pollution noise. Period of time.
There's no durability, durability about this one for structure steel.
Can withstand different loads for a long time. Okay, so can anybody tell me what's the difference between serviceability, durability, and strength? Now, since a lot of you have said stay for a long period of time, and then it can withstand different loads for a long period of time, ability to withstand damage or load. So my question says, what's the difference between durability, serviceability, and strength? Okay. So we are not going to lose a lot of time. Durability is referring whether your element can withstand the weather, okay, the natural weather which is available outside. This is the durability. Serviceability means how long it will live. So whenever we are referring to time, it is serviceability, not durability. Are we fine? Serviceability is referring how long this particular element or structure can be used. Durability, how much it can withstand the weather which is available outside. Are we okay? Now, if we keep a steel bar outside, for a long time, what will happen to the steel bar? You will see after a certain time that the steel bar is going to be corroded, right? It's going to be having a corrosion or rust. Do you agree?
Yes.
Okay. So steel is not good when it comes to durability. You need to protect it because steel is going to be affected by the moisture which is available in the air. It will cause corrosion, rust for the steel. What about fire? Is the steel good for the fire? Is steel good for fire? Now, if you refer back to the process of making steel, steel was a liquid. This liquid was heated. After heated, it was cooled. So now if you are reversing the action by providing heat, you will see that your steel element is going to melt. Do you agree? Do you agree? Are we okay? Okay, so once again, to summarize, when we talk about RCC, we have different materials that can be used, but we need to be knowing why this material has been used and why not any other material. So when we talk about wood is not suitable to be used in Oman. Why? Because we have high temperature and then humidity. Second thing, when it comes to glass, we said there is another material which is glass. Then one big issue is the privacy plus heating, as you said. And then the third type is going to be steel, structural steel. And we said steel is having certain problems. One is being expensive compared to the other materials. Second thing, that it is not good when it comes to durability, and then it is weak when it comes to fire resistance. Are we okay with that? Are we okay with that? Okay. Another advantage of concrete that it can be molded in whatever shape we want. Can you see the different shapes which are available here? We have these things which are wave barriers. Okay. Wave barriers, and then we have road barriers, and then regular framing. One very good advantage of concrete, that is its ability to be molded. If you are having a formwork, your concrete can be shaped on whatever shape you want. Do you agree? Okay. Second slide, after talking about the different materials and then deciding that concrete is going to be the best solution to be used in Oman, then we are going to study the different components. You have studied long back that reinforced concrete is consisting of concrete itself and steel bars. When we talk about RCC or reinforced concrete or reinforced cement concrete, we are referring to a material which is consisting of concrete itself plus steel bar. Now, different things shown here, different actions are shown here. We have compression, we have tension, and then we have the last one, shear. Okay, so we have compression, tension. The first is referring to tension, where he's trying to pull. Then we have compression, and then we have shear. Okay. Now, can you tell me concrete is good in compression, tension, or shear? And a lot of you here memorize the thing. I want you to understand and not memorize. You shouldn't memorize anything in my course. Okay. Can you tell me concrete is good in compression, tension, or shear? In compression, let us start with compression. Is it good or not?
It's good.
Yes.
Yes, it's good. Why? Why concrete is good in compression? What is the reason for you to say that concrete is good in compression?
Because the components of concrete.
What are the components of concrete?
Because always the load came from up.
What about the steel? The load will not come from the up.
No, I mean it is I mean, for graffiti,
Okay.
the load came from up to down.
No, it is metal. Can you explain, Shadow? And once again, I don't want students to memorize. Students should understand. Can you explain how brittle refers to its building compression? Rashid, steel can take more amount of load compared to concrete.
Because of materials of concrete, Mr. The aggregate
Yeah, what about
and
the aggregate?
cement.
Okay. So what about the aggregate and cement which will make it good in compression, not in tension? Okay, no problem. So you said concrete is good in compression, concrete is good in tension or weak in tension?
Weak,
Weak. Okay.
weak
In shear,
intention.
in shear, it's good or weak or bad? In shear, is it good or bad? Concrete? Are you able to see the whiteboard? So I'm going to explain for you why concrete is going to be good in compression, why it's going to be bad for tension, and hopefully you will understand. Okay. So now if we refer to concrete, let's say that we are having concrete here, and then we are having steel. Are you able to see whatever I'm writing?
Yes.
Okay. So let us say that I'm having now for the concrete, if we are referring to our cube, then you will see that we are having gravel particles. Do you agree that we are having gravel particles? Agree? What else you are having inside other than the gravel? So we said first we are having gravel. Other than that, what do we have? We have sand. Okay, so we have sand filling the material, filling the gaps. Agree? Are we fine? Are we okay? So second material was sand. Now if I brought a stone and sand, can they be glued together? If I bring a stone or a gravel and sand, will they be sticking together, or I need another material to stick them together?
Bind them by cement.
Now, if I brought cement and then stone and then sand, will it be sufficient to glue these three, or you need water as well?
Yes, water.
Okay, so what we have gravel, as we said, we have sand, and we have something called as a binder. And this binder is consisting of cement and water. Are we fine? Are we okay? Are we fine till now?
Yes, Mr.
Okay. So if I take a zoomed section, if I take a certain zoomed section, for example, what I'm going to see, there is one gravel particle, there is another gravel particle, between them there is sand, and then there is a glue material between them. Do you agree? Are we okay? Do you agree that this is going to be whatever is inside as a zoomed section? Now, if we see, where is the weak point in this system? What is the weak point in this system? Is it the stone? Or is it the binding material which is inside, between the stone gravel, between the gravel particles? Which one is the weak part?
Cement, sand.
Now, if you are trying to compress, you will see that the gaps here are going to be reduced, right? Do you agree? If you are trying to compress these two particles, you will see that the gaps are going to be compressed and the system is going to be stronger. Do you agree? Now, if I reverse the action by bringing another gravel, once again, and then sand between them, and then I brought here the cement binder or cement water binder, and then I try to apply tension here. What do you think will happen? You will see that these elements are going to be separated from this point because it's a weak point. Do you agree?
Will separate.
They will be separated, right? Okay. Can we give another example so you easily understand? Let's say that I have a pen and I have another pen, which are representing the gravel here. And I wanted to connect these two pens together. Okay. And I have made a glue. I glued both the pens together. Okay. I used tape glue and I glued these two together. To understand any structural concept, try to relate it to things surrounding it, so it will be easier for me. Okay, so I glued the two pens together. Now, in the first scenario, I tried to compress the pens together. Two pens, they were compressed together. Anything will happen to them? Anything, if you are having two pens and then you are trying to compress these two pens together, anything will be happening to them?
No.
Now, if we are having the opposite action by applying tension, what will happen? For a certain time, they will hold. After that, you will see that they will be separated because of the weak point, which is the gluing part. Do you agree? Do you agree? Yes, no. I need to repeat once again. Quickly, otherwise the whole lecture will finish. Okay. So now what we have concluded, we have concluded that concrete acts like particles which are glued together. Whenever you compress these particles, the system will be stronger because we are trying to avoid the gaps. We are removing the gaps between the particles. Now, if you are trying to apply tension, you will see that these particles are going to be separated because of the weak points of the binder. That's why concrete is very good in compression, squeak, and tension, because how the particles are behaving. Are we okay? Now, in the opposite side, we have tension. We have steel. So if we are talking about steel, steel acts like a steel bar. Steel acts like one member. You will not see any gaps between them. Okay? A single steel bar, it will act as a single member. You will not see any gaps between the particles. Once again, concrete acts like two particles glued together, and there is gap between the particles. When it comes to steel bar, it acts like a single particle of single member without having gaps inside. Okay. Now, if you see here, if I'm trying to apply compression, assuming that this is one pen. Okay, assuming a pen once again. It's a single pen. Will anything be happening to this pen? If it's a single pen, anything is happening. Once again, remember in concrete, they were particles and glued together. So it's like two pens connected by a glue. And when it comes to steel bar, it acts like single member because we don't have gaps between the particles. So it's like one single pen. Now, if we are applying a compression to the pen, anything will happen to it? Anything will happen to the pen if you are trying to compress it?
Yes, it will
What will
be
happen to the
broken.
Now, the pen is normally short or long?
Short.
So, do you think it's easy to break a short element? Do you have the pen in front of you? Can you try it and see whether it will break? Once again, to understand structural concepts, try using whatever in front of you. If you have a pen, try it and see what will happen. Okay, so once again, can you try? Do you have a pen in front of you? In front of all of you?
Yes, Mr.
Can you try to apply compression? Anything is happening to your pen? Can you apply compression from both sides? Is there anything happening to your pen? No.
No.
Can you try to apply tension? Anything is happening to your pen?
No.
Nothing. Okay. It means steel is good in both compression and tension. Okay. Steel is good in both compression and tension, but we'll have another scenario. Let us assume that we have a stick. Okay, we are having a very long stick and it's very narrow. Okay. Now, if I try to apply compression, and this was sitting on the ground, So another compression force is coming here. What will happen? Once again, the pen is short.
Bending.
The pen is going to be
Sure.
short. So that's why nothing is going to be happening. But if the element is long, and a good example is the stick, the asa. Yeah? The stick, if I'm having a stick and I'm trying to apply a load, what will happen?
Will
You will see
bend.
that it will lean in one side, either here or it will lean to here. Do you agree? Do you agree?
Yes.
Now, this one is called bending, or is it called buckling? Which one is correct? Which one is correct? Buckling or bending? Buckling. Why buckling? Why not bending? Most of you say that it's buckling. Why it's buckling, not bending?
Because it is vertical.
Right. Okay. Now, let me try to make it a bit easier for you. Okay. If I have an element here, and then I'm putting a load here, is it buckling or bending? This is scenario number 1. Scenario number 2. Scenario number 3. Scenario number 4. Number 1, is it buckling or bending? Okay. Number 1, is it buckling or bending? Number 2,
Bending. Buckling.
number 2 is buckling. Number 3,
Bending.
bending. Number 4,
Buckling.
buckling. So once again, number 1,
Bending.
bending. Number 2,
Buckling.
number 3,
Also
Bending.
bending.
number 4.
Number 4, buckling. It
Okay.
will be bending. Bending.
Okay. So the main difference
No.
between bending and buckling is whatever we call it as how the load is acting on the major axis. First, before deciding whether it's bending and buckling, you need to understand the major and minor axes. Okay. So in this scenario, we have this major axis, and my load is perpendicular on the major axis. Now, if your load is perpendicular to your major axis, then this is called as bending. Is it clear? Are we fine? Now, scenario number 2, this is your major axis. Now, your load is not acting perpendicular, your load is acting parallel or on the same line. It's acting parallel or on the same line. Now, if it's parallel or on the same line, the major axis, we call it as buckling.
Okay.
First, why it's bending? Here, it's an action of tension and compression together. For buckling, the first action is going to happen is compression, and then after compression we have it buckling. Okay. Now number 3, once again we need to see your major axis. So this is my major axis. Now what will happen here? Compression is going to happen first. After compression it will buckle. Why? My load is parallel or on the same line of the major axis. Are we clear? Are we fine? Last option. Once again, this is your major axis. Your load is perpendicular to your major axis, so this will cause you to bend or buckle. Bend or buckle? No.
Cause bending.
Bending. Okay, because your load is parallel, or sorry, your load is perpendicular to your axis. Okay. Now what happens? We said here this element is going to buckle. Now what if we are having a long element as well, but it's very wide? And I'm trying to apply compression force. Okay. Once again, this is scenario number 1. This is scenario number 2. We said for scenario number 1, it will buckle. Scenario number 2, will it buckle? Do you think it will buckle? Do you know the square wood which is used in construction? Whatever called in Arabic al-murabba, do you know?
Yes.
The square wood which is used in construction? Anybody? Do you think it's easily buckling? Do you think that it's easily buckling? No. Okay. So when I refer to buckling, it's not only about the length. When I refer to buckling, it's not only about the length, but two things should be taken into account. One is the length, one is whatever we call it as the cross section. That's why in your design of structures 1 or design of structures 2, you have, whenever you checked for buckling, you have taken L divided by a certain side. Okay, so it's not only length, but it's length and cross section. If the cross section is huge, it will not buckle easily. If the cross section is small, you will see that it's easily buckling. A good example, the stick and the square timber. You will see the stick is easily buckling, the other one is not, even if they are in the same length or the same height. Do you agree? Agree? Okay. So we explained compression and tension. Okay, we said concrete is good when it comes to compression because of the fact that there are different particles glued together. It's not good with tension because these particles are going to be separated. For steel, we said they are good in both compression and tension, but if the element is not long, we shouldn't call it long. If the element is cylinder means it's long, but it's having a smaller cross section. If the element is cylinder, then it will buckle. So once again, concrete is good in compression. It's weak in tension because of the nature of two elements glued together. Steel, because of the fact that it's acting like one element, it's good in both compression and tension. But if we are dealing with cylinder elements, then cylinder elements are going to buckle. Okay, so that's related to compression, tension, steel and concrete. The last thing that we are going to take is shear. Now let's say that I'm having a steel bar here, which is my pen. Okay, so once again, this is my pen. And then I have another two pens glued together. Okay, so once again, this is acting as steel as its single element. And these are two elements glued together, which is acting as a concept of concrete. So they are glued here by a binder. Now what we understood that shear are different forces, right? We have two different direction forces. So I'm assuming that they have one over there and one here. Which one you will feel that it will be weak? The single pen or the two pens glued together? Which one is going to be weaker? which one will try to break? Is it the single pen, which is steel, or is it the two pens glued together, which is concrete? Which one is going to be strong?
Steel will be strong.
Steel will be stronger. Why? Because we don't have any point which is weaker than the other point. In concrete, do we have points which are weaker than the other points?
Because it's one component.
In concrete, do we have places which are weaker than the other places? We have the glue which is weaker, right? Okay. The glue which is weaker than the gravel itself. So in that scenario of concrete, it will be affected by shear more than steel. Is it clear? So when it comes to shear, you can say that steel is good. It acts as a single element. Concrete is going to be a little bit weaker, not weak, but little bit weaker, because of the fact that we have weaker points in the system, which are the gluing parts. Are we clear?
Can you repeat, Mr. the last point?
Once again, for the steel, we said we don't have weak points. Each and every point in the steel itself are having almost the same strength. So it's not easily cut. When it comes to concrete, we have weaker points and stronger points. So the weaker points are the easily points to be cut, right? So if I try to evaluate which one is better to resist shear, then I would say steel is better than concrete. Steel does not have weaker points, weaker clear points. Concrete is having. Are we okay?
Yes, Mr.
Right. Okay, so I have explained these three. And once again, I have explained for you the concept of having one single element or steel bar, and then the components which are glued together, which is a concrete. Are we okay? So do not memorize, understand. And once again, link whatever you are taking to things surrounding you. Are we fine?
Yes, Mr. Fine.
Now you see what happens here. Just to clarify the compression and tension, to make it a bit easier. Normally the element will be in a regular state, not in compression, not in tension. But whenever you are trying to load it, it depends on how you are loading it. You will see that whenever it bends, you are going to have compression and tension. Now, can you see here that each and every point up and down are having exactly the same thing? The same length, let's say. Do you agree that this length is the same as this length? Do you agree that the top and bottom fibers are the same? Now, what about after loading? What about after loading? Do you think they are the same? Do you think that this is the same as this?
No.
No. So where is your tension and where is your compression? Tension is the longer part, right? Compression is the smaller part. When you apply tension, you will see that the element will be longer. When you apply compression, the element is going to get shorter. So which one is long? Which one is short? So you have the upper portion is going to be tension, the bottom portion is going to be compression, right? Are we clear? Okay. For shear, to avoid shear failures, we normally supply different solutions. Like here, they are supplying steel plate. I don't know if you'll be able to see it or not. Or we can apply something like a cap. We call it as a drop panel or a column cap. Okay. These are supplied in flat slab system. We are going to see it further, but this is like a solution to the problem of shear. Okay. Either we can have a plate here to stop the area which is weak or wherever there is high loads. And we have in terms of flat slabs, we can have either drop or a column head as well. So these are the first things that we have discussed about reinforced concrete. The other things we said, if you remember, there are two things which are affecting our steel. One is water, another one is fire, if you remember. Right. So another comparison for us is to understand concrete is good at what and steel is good at what. Now, when it comes to water, which one is good, concrete or steel?
Concrete.
Concrete is good, and you can see from the pictures. I think the pictures are very clear. Actually, in order for us to let the concrete gain its strength, we are putting it in the water. So concrete is not affected by water. Now, in the opposite, what happens to the steel? You will see that
Corrosion will be rust.
steel is going to be having corrosion or rust. Are we clear? So when it comes to water, water exposure or the weather exposures, we say that steel is weak since it will be affected. Corrosion might be happening. Concrete is going to be having lesser effect. Are we clear? Lesser effect in the sense that you are not talking about, for example, seawater. Seawater is going to be having an effect on the concrete. Okay, and we will see that further. What about fire now? Which one is going to be stronger? We said steel is not good for fire, right? We said it will melt after a certain time. What about concrete?
It will withstand.
It will withstand. Why it will withstand? Now, to understand this point, you need to return back to the raw materials. Now, steel, we said it was liquid, heated, and then cooled. Now, if you are reversing the action, you will see that your steel is going to melt. Now, for concrete, the raw materials, the raw components of the concrete are gravel, sand, cement. Gravel and sand are not easily burned. You cannot bring a stone and then burn it. Sand is going to be affected, but after a long time. Okay. So now what you can see that steel is weak in terms of fire resistance. Concrete is good when it comes to fire resistance, and that's returning to the concept of raw materials. What are the raw materials of each and every element? Now here a good example is World Trade Center. Do you remember that 9/11? 11 September, right? It was 11 September, 9/11. No. Do you know the Trade Center, the World Trade Centers? In
Yes,
USA,
yes, Mr.
whenever they were hit by the what you call airplanes, do you remember? They were hit by airplanes, right? Now, if they were hit by airplanes, they're hit by the airplanes. Let's say that I'm having my what you call it? I'm having my building here. This is the World Center, and then we are having the airplane coming from this side and hitting it. You will see the most appropriate failure is going to happen. If this is failing because of the airplane, you will see that it will fail in this way. It will fall down on one side, right? Do you agree? Do you agree that because of the high speed, the high damage caused by the airplane, it should lean your structure to one side? Do you agree? Now, whatever has happened in reality in that World Trade Center is not this case. Now, if you have seen, and later on you can go and check yourself, you will see that this particular building was not falling in one side. This particular building was falling directly vertical. And the main reason that this particular building was falling vertical is the fact that it's not failing because of the airplane damage. it was failing because of the steel columns melting. Okay. So what happens in this particular figure? If you see, it was hit. After hitting, fire is caused. Because of the fire, the steel columns were melting. Because of the steel columns melting, the floor just dropped above or on the other floor, which causes the whole collapse of the building. Okay. So once again, steel columns are very, very critical when it comes to fire protection. Now, how would you solve the problem of the steel having rust or corrosion? How would you protect your element from having corrosion? You will be protecting your element from water or corrosion by applying good cover. You have studied cover, right? Do you remember cover?
Yes.
Concrete will not be painted by applying cover. Can you see the cover here? So what you have done for cover, you have put certain element. Cover is normally from concrete, so you have applied certain elements which will not be affected by water. After that, you supplied your steel, so water will not penetrate to your steel bars unless there are cracks inside. Okay, so the proper solution to avoid any corrosion is to apply proper cover. Can you see the cover here in case of the slab and in case of the beam here? Can you see these covers? These are the cover blocks that you are designing and you are taking into account while you are doing the design. Now, when it comes to steel and fire, there are different methods. One, as Khalid said, by painting it, or the other method which is more effective, which is called encased. Encased in the sense that you are having, this is your steel column, you are covering it up by concrete. So whenever you are covering it up, we call it as encased. So what happened in this scenario? Fire will not penetrate easily to the steel column going inside. Why? Because I have covered it with concrete. Okay, so this is whatever we call it as a composite or a composite structure. Composite means you are having or mixing two elements together, which are RCC and structural steel. Are we okay?
Mister, but there is building with a steel structure only.
Yeah,
What
it should
they
have
do?
it should be painted. Otherwise, it has a very high potential to fail if there is any case of fire.
Okay.
So normally, if you are seeing the steel elements like this, they are either painted or the designer is having the responsibility of any fire case. But normally they will be painted. Municipality will not approve anything without having the steel columns or steel elements painted against fire.
But this painted is withstand with hours, right? So
Yeah, of course.
like
Even
some period of
even if you are designing for concrete, you are designing it for certain hours. This cover will stand for certain hours. These hours are sufficient for you to be evacuated. It means that when I design my building for 2 hours or 3 hours, for example, if I'm designing my house, I require 1 hour of fire resistance. Why? Because if you are staying in your house, it will be easy for you to go outside from your house. You don't require a lot of time to be evacuated. Now, for example, when it comes to a hospital, when it comes to a mall, a lot of people are there, so it requires more time for evacuation. In that scenario, you need to take more fire resistance hours for the design. Are we clear?
yes.
So it's not possible that you are going to make your steel protected forever, but this fire resistance protection is going to ensure whoever is inside that particular building to be evacuated without having severe issues. Are we fine?
Yes, Mr.
There is a video. Okay, now the remaining things are going to be video. I'll just explain them roughly. So I have we have modeled for you one building just to explain for you the different views. These are the things that we are going to refer to. These are a recap of whatever you have studied. So this view is going to be called as 3D or perspective. Okay. So now you can see we have different floors here, different levels. Now if you can see, we have different setbacks. Are the distance from the border to the inner house, from the border of the house or the block to the border of the house. So according to municipality, you need to keep certain value for the setback. So front setback is normally 5 meters because you will be putting your car inside, and then back is normally around 3 meters. And then we have the side setbacks is around 3 meters or 2 meters, depending on the situation. Why we are keeping the side setbacks? So that you will be having a privacy. Your other neighbor will not be able to see whoever or whatever action or activities you are doing inside your house. Okay. So this is an explanation of the setbacks. So here they have been, or we have illustrated for you the setbacks. And then if you see, now this is whatever we call it as elevation. So elevation is whenever you are seeing your house from outside. It's a 2D view. Okay, so different elevation, different sides. So we have taken the 3D or perspective, and then we have taken the elevation, which is from outside. Okay. And then now we are having plan. So whenever you are seeing your building from the top, then this is called as a plan. And this is whatever we call it as an architectural plan. Okay, this is whatever we call it as an architectural plan. Now I'm trying to take a section. Okay, so once again, this is not a section. This is an elevation from outside. If you are seeing it from outside, it's an elevation, but this is not rendered. This is not with colors. These are different elevations. Now, whenever you are cutting your building from inside, that one is to be called as a section. This is a colored version of the elevation. So once again, whenever you are cutting it from inside, you will see your section. So hopefully, this is a good example of section. You can see that we have cut the building from the middle, where you can see your staircase and the other elements. Okay, so it's very important for you to understand what's the meaning of 3D, what's the meaning of plan. Plan is seeing the building from the top. If you are seeing it from the side, then it's elevation. If you are cutting it, then we call it as a section. Are we clear with the building views? I assume you have studied all of these in building drawing. Yes. And then we are having the structural and architectural drawings. So you can see here I have 3 windows. One is the 3D, just to illustrate for you. And then we have the architectural drawing, and then we have the structural drawing. So you will understand the difference between these types of drawings. Now the 3D, if you see the 3D, okay, the 3D will help you in understanding the architectural and the structural. Okay. Okay. So now one thing before we jump. Now, if you can see here, you can see in the architectural drawing you have a lot of secondary elements like the steps, like the furniture, windows, doors, which are not available in the structural. In the structural layout or the structural drawing, you'll be having only the structural elements, which are slabs, beams, columns, and then foundation if you are talking about the foundation layout. Okay, so now if you see, we have taken, these are different floors, so ground floor, first floor, roof and upper. Now you can see that certain areas is considered as a terrace, which is this area. Can you see this area? So it's very important for you to know how to read and how to understand the drawings. So I try to bring a 3D and 2D drawing so you'll be able to understand. This is going to be your first floor, but this is going to be your roof of the ground, which is going to be your floor for the first floor. We have roof and we have floor. Okay. So the roof for the ground floor is the same as a floor for the first floor, which is this one. Okay. And then we have the other level. So this is my other level where you can see it here. The same thing goes here. And then finally we have our penthouse, or whatever we call it as the upper roof, okay, where you are going to supply your water tanks. So you can see it here that this is the upper floor and this is your penthouse or the upper floor as well. Okay, so this is an illustration of the structural drawing and architectural drawing. Whenever I'm starting the course, I'm assuming that you know all of these things. Okay? So we will be able to start the designing procedure. And you will not be able to design properly unless you understand these things. Okay? And then we have structural elements. So once again, I have modeled for you a building in which I'm explaining the different structural elements. So now if you see here, I have tried to put the maximum number of elements. Rather than putting a picture for you, I have tried to show you in this way. So these are your beams. These are your beams, which are the horizontal elements. And then we have columns. So these are the columns. We have different levels of columns. If you see here, we have columns going to, let's say, the third floor, and then there are columns which are going to the penthouse, whereas wherever there is a stair room. Okay. And then we have, this is whatever we call it as a shear wall. Whenever you are having a concrete wall, we call it as a shear wall. Columns are vertical elements, and then we have something called shear wall and core wall. Okay. So shear wall are representing RCC walls, which are going to be protecting you in case of lateral loading for wind and seismic. So one rule from the municipality says that if you are designing a building which is more than 3 stories, you cannot have it without designing a lift, and lift is acting as shear walls or a combination of shear walls. Okay, so this is the first shear wall. Once again, shear wall is an RCC wall which is fully concrete and steel. So this is the first shear wall, second shear wall, and then we have the third shear wall. Whenever you combine, or whenever there is a combination of walls, we call it as a core wall. Okay, so a very good example of core wall is always going to be your lift. Lift is a combination of shear walls. Whenever it's a combination, we call it as a core wall. Okay. Another example of shear is this one. So this is a single wall where we call it as a shear wall. Okay. And then we have different elements as well. Slabs we are going to highlight. If you see, slabs have been highlighted. We have different slabs, and then we have the staircase slab as well. Okay. So this is acting as your staircase. Okay. Now, of course, we are going to have different depth of slabs. We are not going to have the same depth of the slab. A lot of students are wondering, if we are having different depth of slabs, how come we are having the same level? Now, the top level of the floor is going to be always the same, but the bottom level is not going to be the same, which is hard to be visualized by you. We notice whenever we are moving on things, but if we are looking to it from the bottom to the top, it's not easily verified whether the depth here is 160 or 150 or 140, or they are the same. So we have different types of foundation here. I tried to model for you. So we have raft foundation, we have isolated, we have strip on what you call on different columns. We have raft foundation here. Okay. We have a pile cap. We have as well. We have a strip on wall. We have a strip on a group of columns. We have raft on piles. Can you see here? You can see that we have different types of foundations. We have you see here. We have on the core wall, we are having a raft foundation. We are having isolated foundation here. We have strip foundation on group of columns. We have a strip foundation as well on a wall on one side. We are having pile cap, so a cap, a slab, and then supported by different slabs. We should be studying this one in geotechnical engineering, which is a type of field foundation. And then this is raft, which is supported by end-bearing piles. So these are the different elements which you should know, which we are going to deal with. We are going to deal with different slabs. We are going to deal with different types of columns, different types of foundations. Unfortunately, being we have studied on design of structures one, so we will not have any deal with it once again. The last thing that we are going to highlight for you before closing up this particular lecture is going to be the structural systems. So you should know that we have different structural systems. This is whatever we call the regular structural systems. These are all skeleton or frame type. Okay. So we have the first type, which is a regular frame. You can see it's columns, beams, slabs only, whatever we refer as solid slab system. And this is good for 3 stories and lesser. Okay. So you can see in this framing, you are seeing your slabs, beams, and columns. Okay. Now the other system, or let us see a side. Okay. So you can see in this side, it's a regular framing, beams, columns. Now the other one is representing a flat slab. With whatever we call it as a drop panel. Now to avoid shear, because we don't have beams here, to avoid very huge shear on areas of the slabs, because we have okay. Now if you see here, whenever there is a column, we don't have beams in flat slabs. So to avoid very high shear, what we are going to do, normally we supply something called drop panels, extra thickness of slab or extra slab, smaller slab on the position of the column. We call it as a drop panel. There is a column head as well. Different types of solutions are there. Okay. So this is what you can see. Now if you concentrate, you will see that there is extra thickness on the position of the column. This is whatever we call it as a drop panel. And you can see that we have projection. There is a cantilever part here. So normally for residential commercial buildings in Oman, we are using a lot of flat slab system. So either flat slab, if it's like 3 stories and above, or residential commercial, normally we prefer to go for flat slab, either having fully flat on columns, or whatever is used mainly, which is flat slab plus columns and core wall, which is the last option. So now if you see here, in the first model, it was beams, columns. Here in flat slab, we don't have beams, only on the borders. And then in the last option, which is going to be shear wall, columns, and then flat slab. The slab can be reinforced or it can be post-tension. So now if you want to see a plan, so this is a plan of your structural slab layout. Here we have core walls. So this is a core. This is a core because it's a combination of 2 walls. Core. This is a core. This is a lift, which is representing a core wall. Now this is one wall. This is one wall. So these are acting as shear walls. And this X is representing an opening. Whenever you are having a lift, of course, there will not be a slab, except if you are talking about the roof slab. Explaining that, we have finished today's session. If you have any question, you can ask. If you don't have any question, then we have finished our session.
Mister, you said second system.
Okay.
They are using flat slabs in residential and commercial.
Yeah.
Why
it's commercial building?
Why it's using only flat slabs?
Flat slab will give you a longer span between columns to columns.
So avoiding the beams, a lot of beams.
No, it's not about avoiding the beams, but normally whenever you are having your flat slab system, the own weight, by removing the beams, the own weight of the whole system is going to be a little bit lesser. Whenever it goes lesser, you can extend the span between columns to columns. The same thing whenever you are going to go for waffle slab. If you want longer span between column to column, you can use waffle or rabbit slab, or you can use post tension slabs. So different solutions, either by reducing the weight of the slabs. Reducing the weight of the slabs will be happening by removing certain parts, like in case of ribbed or in case of hollow core slabs, where you are removing certain parts of the slab, or systems like CopyX. You can search about CopyX, where we are removing certain parts of concrete, supplying either foam or bolts to make our slab weight lighter. If the slab weight is lighter, then you can extend the column from one side to another side. So normally, flat slab is good for residential, commercial, because you want to have a longer span between the columns. واضحة after the class, inshallah. Any other question? No question.
No, for me. Thank you.
Yeah, at the end of the class. So I'm going to upload for you the handout and the PowerPoint. The videos will be available. Available in the channel, and then you can download them. You cannot download them, but I'll upload them in YouTube as well, where you can see them.